Good morning, one and all. In today's lecture, we'll solve the numerical on bending stress again. See, guys, in this numerical, you have given one timber rectangular beam. Okay, in the simply supported beam, have given, and there is a overhead UBL span is given from A to B meter. The distance is given 8 meter. Okay, and the point load is at the 3 meter from the A support. Okay, 10 kilometer, and UDL value is given. This UDL is run over the given timber rectangular beam is 12 kilonewton per meter, and one relation is given. The depth of that timber beam, rectangular beam, is twice the width. Okay, means you have given the D is equal to 2b. D is equal to 2b. Okay, depth is given 2 times of the width of the beam. Okay, then there you have given the bending stress induced in the given timber rectangular beam is not to exceed than 8 Newton per mm square. Not to exceed means you have given the maximum value, sigma max. Okay, they are not exceed than 8 Newton per mm square. Then what we want to calculate? We want to calculate the dimension of that rectangular timber beam. Which dimension? D is equal to and B is equal to how much? Okay, that dimension we want to calculate. We know the bending formula. With the help of that bending formula, we can calculate the value of D as well as B. Then before going on that, we require the support reaction, and we want to find out where is the shear force is 0. Why where is the shear force is 0? Because we require the maximum bending value. What we require? Maximum bending value. And where we get the maximum bending value? Where is the shear force is 0? Means we want to calculate the section in this given simply supported beam. Okay, where is the sign changing in the SF diagram. Then how to calculate all these things? We want to do some calculations. First we will calculate the support reaction. First is the support reaction. You know how to calculate the support reaction. There is a, we will consider summation of Fy is equal to 0. Vertical we will consider positive and downward negative sign convention. Okay, then Ra plus Rb, this one. Then minus, there is a 10 kilonewton load. Again minus this load, minus what? 12 into what? W into L, and where is that? At the CG. But we will consider the only vertical, upward and downward forces. 12 into 8 is equal to 0. Means you will get the Ra plus Rb is equal to what? If you have calculated 96 plus 10. 96 plus 10, 106 is there. Okay, this relation will get with the help of the calculation. Then summation of Ma is equal to 0. We type a point is equal to 0. Then check that this is going clockwise direction. Clockwise, 10 is going clockwise. 10 into what? 3 meter up to 8. Then there is a one more load is at 12 kilonewton. Then plus, again this is going clockwise direction, 12 into 8, and where is that? This half distance. Okay, you have calculated the movement. That's why 8 divided by 2 means 4. Here you will get that point load. Okay, already we have seen the unit number 2. Then this is going anti-clockwise, minus Rb into what? Total distance up to the 8 is equal to 0. Okay, if you have calculated this Ra and Rb, then Rb is equal to, you will get 51.75 kilonewton. Okay, if you have converted into the Newton, then multiply by 1000. 51750 Newton is there. And what is the value of Ra? Once you have put this Rb value in that equation, then check that you will get the Rb is equal, Ra is equal to 54.25 kilonewton. Again convert into the Newton, 54.250 Newton. Okay, I will write here that value. Ra is equal to 54.250 Newton, and Rb is equal to what? Rb is equal to what? 51750 Newton value. Check that Ra, and once you are getting the Ra and Rb value, then we want to calculate the maximum bending moment. Before going on the maximum bending moment, we want to check where we will get the sign convention is changing in SF diagram. Then how to check that? Once you have got the Ra and Rb, then do the SF calculations. One value you will get the positive, and another value, next value you will get the negative. Then there you will get the sign changing in the SF diagram. Okay, we will check SF at A point. Check that SF at A point. This is the positive 54250 Newton is there. The next point SF at C, just left side. I will take the just left side. This one positive 54250. Then minus. Why minus? Because this load is acting in downward direction. This 12 kilonewton. 12 means you can convert it to the Newton. Okay, you can convert it to the Newton per meter. Means 12 into 1000, 12,000. Right? We'll write here this one. See, here is it 12,000 Newton meter, and this load is a point load 10,000 Newton. Okay, I have converted to the Newton meter and Newton. Then minus this 12,000, minus that this 12,000 into what? Into what? This distance 3. Okay, we want to convert the point load. 12 into 3 is there. We are consider only A to C section. Okay, and check that how much you will get. SF at C, you will get just left side 18,250 Newton is there. Okay, this is the force. Okay, and SF at C just right side. We are coming the just right side. Then we will check. Already we have calculated 18,250 minus this 10 kilonewton is what? 10,000 is there. Okay, then you will get the 8,250 Newton is there. Okay, then next is the B point. Okay, if you have calculated SF at B just left side, SF at B just left side, already we have calculated. Check that SF at B just left side or at B, you will get, then you will get this value minus 51750 Newton. Okay, no need to calculate. You will get this value in the minus. Guys, check that SF at C point just right side, we have the positive value 8250, and SF at B just left side, we have the minus value. When you draw the SFD, then you will get the sign changing in the SFD in between B to C, in between C to B, or in between sign changing in between section. Which section? C to B is there. Okay, C to B is there. We want to calculate where we get the shear force is 0. We have find out the sign changing in between the section B and C. Then exactly we don't know where we will get the 0. Exactly exactly we don't know where we will get the 0. Then what I will do here one thing, in the simply supported beam, I will consider the 0 distance from the B support. Okay, x distance from the B support. Suppose here I will take the section XX and distance from the B support is a consider x. There will get the 0 shear force. There will get the 0 shear force. Then what we will do? What we will do? Yes, anybody? Then check the summation of that section in the step diagram. Check that this is going upward direction, but in which side? Here is our section, right side. Means we will get the minus RB. Means we will get the minus RB. Only the summation of the vertical forces. And there is one more load in between that section. Okay, at a distance of 12,000 Newton meter. This is acting in downward direction. Means which side is acting? That side downward. Means here is upward. Check that. For the section left side, right side downward, then upward. Then we can consider the positive. Then reverse of that, this one upward and this one downward. Then we will consider the negative. Remember that when you calculate from the right hand to the left hand. Okay, then check that this force is going upward direction. Here is our section, right? Means this one minus RB. Don't confuse, and plus here is a 12 kilonewton. Means 12,000 Newton is there. Is equal to 0. The summation of SF for that x distance is minus RB plus 12,000 is the value of UDL into distance. X is there. X is there. Okay. Then we have calculated already RB value. What is the value of RB? Minus 51750 plus 12,000. X is equal to 0. Then you can calculate x is equal to, you will get the 4.3125 meter is there. And where will get the shear force is 0 from the B support, 41.3125 meter. Okay. Once we have calculated this distance, x distance, x is equal to 4.325 meter. Then we can calculate the maximum bending moment for that distance. Yes, what is the maximum bending moment for 4.3125 meter? Bm max is equal to check that RB. Here is it. We are going right to left. RB is going anti-clockwise direction. Means here is a clockwise direction. Okay, remember the sign convention. Then here is a clockwise direction. Here is anti-clockwise, means positive. RB into x distance up to the x. What is the x distance? 4.3125 meter. Right. Then again check that there is a 12,000 load is acting in downward direction. Means this is at here. Okay. This again going clockwise direction. Means minus this 12,000 into what is the total distance? 4.3125 into again 4.3125 divided by 2 is there. Then we know the RB value. Put this value in that equation. RB is equal to what? RB is equal to already we have calculated 51750 is there. 750 is there. Okay. Then you will get the 111.585 is there. Okay, check that. Sorry, 111.585.9375. This is in Newton meter. This is in Newton meter. If you want to find out this convert into the mm, then what is the value of that? You have to multiply by 10 raised to 3. You know the relation. 1111.585.9375 2.75 into 10 raised to 3. This is in Newton mm. This will get the maximum bending moment at point this section XX. Is where our shear force is 0, there will get the maximum bending moment. What I will write here, Bm max is equal to 5.975 into 10 raised to 3 Newton mm. Okay, force into distance, right? Once you have calculated all this value, then we know we have seen the section modulus for the rectangular beam in the second lecture. What is the section modulus for the rectangular beam? It is denoted by the Z. Z is equal to, already we know, I by y. What is the I? BD cube divided by 12. For the rectangular beam, BD cube divided by 12. B is there, D is there. BD cube divided by 12. I is equal to. And what is the y? Y is the maximum. Again D by 2 is there. If you have calculated this, then you will get, see this D cancel, 1D, D square is there. But here you will get the BD square by 6. BD square by 6 is there. If you have solved this, right? Remember that Z is equal to what? Z is equal to I by y is there. I by y is there. Okay, you will get the BD square by 6 is there. But we have given this relation D is equal to 2b. D is equal to 2b. I will put that in this formula. 2b. D is equal to 2b. B as it is. 2b square divided by 6. Then b into this one, you will get the again we will check that 2b square, 2b cube divided by 6. 2b square into b cube, and here is you will get the 6. 4 is there, no? Yes, 2b square by 6 is there. You will get the 2b square divided by 3 is there. Yes, this is the correct. Z is equal to, you will get the 2b square because 4 is there, na? 4 divided by 6, you will get the 2 by 3 is there. Once you have got the Z value, then easily you can calculate the value of B and D. We know that the formula M by Z is equal to, or we know the definition, sigma max is equal to M by Z. Sigma max is equal to M by Z. We have seen in the first lecture, right? And what is the M? M is equal to, we will get sigma max into Z. We have all the value, then put that value in that equation. What is the M value? We have calculated the maximum bending moment. 5.9375 is equal to, what is the value of sigma max? This value is given here into, what is the value of Z? Z also we have 2b cube divided by 3 is there. Okay, here is the only one constant is the b constant. If you have calculated the b, then you will get the 275.5 mm. Okay, and you put this b value in that equation, then you will get the d is equal to 2b. D is equal to 2b. Means double of that, you will get the 551 mm. In this way, you have to calculate the timber beam rectangular section value, D and B value. Okay, how are you getting? This is totally depend on the unit number 2. Up to that maximum bending moment, you have to calculate the, use the unit number 2. Then after that, you know the formula. M by I is equal to Z, or Z is equal to, we can write sigma max into M. Okay, use that formula, then you will get this value B and D. Today we will stop here.